we have methane, ethane, and propane. They are gases and used as fuel. As the molecule gets bigger, the boiling point goes up. If an oxygen is added, they become alcohols, methanol, ethanol. The oxygen can be added to propanol in two ways. The hydroxyl group can go on in the middle, or it can go on the end. So on the end is propanol, in the middle is isopropanol. The oxygen makes a triangular looking structure. Notice that the oxygen can be a linking group between two carbons. This is diethyl ether. There's two electron clouds that stick out the back of it. But this is a very strong bond, and found in carbohydrates especially, and with variations in fats, and with variations in the rails of deoxyribonucleic acid. Oxygen can form a double bond, very similar actually to the way that carbon does. There's a pi bond that goes through perpendicularly through the oxygen and pushes this out flat. So if you notice this one, this one, and this one are all in one plane. And then there's two electron clouds that stick out here and here, which would also be in the same plane. This shows the carbon-carbon double bond. We are looking for visual images, and the image is that this bond does not rotate. So that these two structures are not the same. This one has the two methyl groups on the same side. This one has the two methyl groups on the opposite side. And these are not interchangeable. This is the trans form, and this is the cis form. And notice that these structures are flat. Notice that this double bond is flat. The simplest compound of nitrogen is ammonia. It has 3 hydrogens, and they're pushed out into a pyramid. So there's a cloud that comes out on this side. There's a cloud that comes out on this side. These are found in amino acids and nucleic acids and elsewhere. We are striving for visual images of the structures. This is a pyramid, but it's not very rigid. It reminds me of the cartoon where the umbrella flips inside out on a rainy day. Organic chemistry people call this inversion. Ammonia, the amines, including ammonia, invert very readily. Nitrogen has the highest abundance in protein. This is phenylalanine, an amino acid. The amine group is right here. And this is the carboxylic acid, and this is an aromatic ring, which we'll get to later. But this is the amine, and notice that it inverts pretty easily. Nitrogen can form double bonds also, and the double bonds are similar in character to carbon, in that there's 2 of these, there's a double bond, and then there's 2 coming out here, and there's 2 coming out here, but the one that comes out here is an electron cloud. The electron cloud is particularly important because it contributes to the hydrogen bonding that forms the base pairs in deoxyribonucleic acid. And this is Avogadro software, and the software is designed to give us the most energetically favorable state, this is kind of a realistic sort of look at the molecule. And we can see that the pyridine, it's a pretty stiff compound, pretty stiff, stable, rigid compound, very much planar.